So yeah, you can see this is the second time I tried to make this video. So complex numbers, that's what we're going to talk about. And they sound bad because of the name. The other name for them is even worse. So this is called I, and it's defined to be the square root of -1. So what these are things that will allow you to take square roots of negative numbers, which turns out to be handy. Now, they actually do have meaning in real world applications, mostly like higher level math, so physics and quantum physics, quantum mechanics, electrical engineering, stuff like that. They are awesome, okay, but the reason that the names really stink, these are called imaginary numbers. They are real, but they are called imaginary numbers. Like if you were to try to take the square root of a negative, you'll get this error right here, non-real answer. So let me go over real quick how they come up with all of these. So the first one is actually a given. It's assumed. We assume that I is equal to the square root of -1. I is equal to the square root of -1. Now to figure out I squared, they just do square root of -1 and square root of -1. But instead of it being the square root of 1, what happens is they just cancel out these square roots, because that's what happens when you multiply two radicals. The square roots just cancel. So I squared is equal to -1. Now for I to the third power, what they do is they take I squared and they multiply it by I. Well, I squared was equal to the -1 here. So you end up with -1 times I, and -1 times I is just negative I. All right, and the last one here, I to the fourth. Let me think, how am I going to do this one? I to the fourth. Oh, that looks really ugly. I to the fourth, I'm going to do it as I squared times I squared. That's how I'm going to think of it. Well, I squared is equal to -1. So you really have -1 times -1, which is 1. And that's how they get these four here. So I would write these down if I were you. They're going to be helpful in doing stuff like this, I to the 55th, all right? But mainly this one right here, that I to the fourth equals 1, that's going to be the really, really, really helpful one. Okay, so to simplify I to the fifth, what we're going to do is we're going to take away as many of these I to the fourths as we can. So let me see here. 52 divided by 4. Yeah. So 52 divides by 4 evenly. So what I'm going to do here, I'm going to rewrite this as I to the 52nd times I to the third power. So when you multiply these, you just add the exponents. That's why we can rewrite it like this. Now, because 4 goes into this evenly, I can think of this as I to the fourth. I know this is going to look really confusing, but the way that I implement it is actually not so bad. To the 13th power. All right, and that's because when you have a power raised to a power, you get to multiply those, and 4 times 13 is equal to this 52. So this part is equal to that I to the 52. I to the third power left over. Now, notice I to the fourth, that's just equal to 1, and so you get 1 to the 13th power. So this part, we can actually completely ignore it. It's all gone. And this part becomes our answer, I to the third. So that's negative I, right there, negative I. So what we're going to do is we're going to take off as many 4s as we can. So like I figured out that 52 divides by 4. So basically I took away 52 of these and I was left with I to the third. And then I just used my little chart over here. All right, 76. I'm pretty sure that 4 divides into 76. 76 divided by 4. Yeah. So this one, if I take away all of the 4s, I'm actually just going to take away I to the 72. I'm going to leave this one just so you kind of see what's happening. This I to the 72 is equal to 1 because 4 goes into it evenly. Like, it's equal to I to the 4th, to the 18th power. All right, 4 times 18 gives me the 72. And since I to the 4th is equal to 1, you get 1 to the 18th. And that's why this whole thing is just equal to 1. And this is equal to 1 as well, I to the 4th. So basically, if you have a power that divides by 4 evenly, then that piece is just equal to 1. All right, I to the 33rd is the same as I to the 32nd, which divides by 4, times I. This is equal to 1, so it goes away. And so your answer is I, or square root of negative 1. Let's see, 118. Let's see, 118 divided by 4. No, but it's close. Let me try 116 divided by 4. Yeah, so 116 divides by 4 evenly. So I rewrite this as 106, as I to the 116th power and I to the 2nd power. This part's equal to 1, cancels, and so you're left with I squared. And I squared was equal to negative 1. And that's that.